In this video, we're going to do a few extra examples involving inverse trig functions. So remember, in order to have an inverse trig function, so for the sine function, we had to restrict the domain to negative pi by 2 to pi by 2 so that we get this one-to-one function, so it passes the horizontal line test. So we restrict the domain, then we can define our inverse sine function to be y equals sine inverse of x, or arc sine, sometimes they use. So the way we define it is if y equals sine inverse of x, that's the same as saying sine of y is equal to x. Okay, so the domain and range switch. So the range of sine x is negative 1 to 1. So that's the domain of the inverse function. And the range is this restricted domain. So that's what the graph looks like. And I think I have an example here. Okay, so we want to find sine inverse of negative 1/2. Okay, so that means that we want theta, because the outputs here are angles. So we want theta so that sine of theta is equal to negative 1/2. And theta should be between negative pi by 2 and pi by 2. Okay, so sine of theta being negative means, and knowing that theta is either in quadrant 1 or quadrant 4, means that theta must be in quadrant 4, so that we have a negative sine value. So we want to know what theta, so 1/2 is one of our special angles. So we want to know what theta has sine being 1/2. And that is 30 degrees. So that means that our theta here is going to be negative pi by 6, or negative 30 degrees. Okay, now remember the trick. If you're in degree mode, okay, and you enter sine inverse of negative 1/2, it's going to give you 30. Negative 30, sorry. So you're going to know that that's the degrees, and then you want to convert that to radians. Okay, so this would be negative pi by 6 as our answer. So similarly, sine inverse of root pi by 3, root of 3 over 2, sorry. So we want sine of theta equal to root 3 over 2, so it's positive. So theta is in quadrant 1. Again, root 3 over 2 is our special angle, so theta has to be 60 degrees or pi by 3. So this value is going to be pi by 3. Now, for these two, so 3 pi by 8 is between, so it's positive, so okay, it's actually bigger than 0. Okay, but it's less than pi by 2, because pi by 2 would be 4 pi by 8. Okay, so it's less, so it's in this interval. So that means that this is equal to just 3 pi by 8. Okay, so the sine inverse and the sine cancel because 3 pi by 8 is in this interval. Okay. Similarly, 0.6 is in this interval here, and we're doing sine of sine inverse. So again, this is going to be 0.6. So the sine and the sine inverse just cancel out. Okay, so now I left one here where we're not in that interval. Okay, so 5 pi by 8 is in quadrant 2. So let's just draw the picture here. Okay, so if I split pi into 8 bits, okay, I split it in half, and then I split the halves in half. That's 4 bits, and then I split each of those in half. Okay, then each of these is pi by 8, so now I just have to count. Okay, so it's going to be 4 to get to pi by 2, and then one more. So my terminal side is going to be this one here. Okay, so that's my angle, theta, which is 5 pi by 8. Okay, looks like that. So I want to know, where does it have the same sine value, because I'm talking about sine. So I'm going to take this right across. My picture is not very good. It should be right there. So the reference angle is going to be this one here. So with this terminal side. Okay, so that's going to be 3 pi by 8. Okay, so this is actually equal to sine inverse of sine of 3 pi by 8. And now I'm in the right interval, so the sine inverse and the sine cancel out, and I just get 3 pi by 8. Oops. Okay, so this thing here is equal to that thing there. That's why I can do that switch, because they have the same y value on the unit circle. Okay, so now we're moving into cosine. So again, we restrict the domain, but this time it's 0 to pi, so we're in quadrants 1 and 2. And here we want cosine inverse of root 2 over 2. So we want theta so that cos theta is root 2 over 2, and theta is between 0 and pi. So root 2 over 2 is a special angle. Okay, so this means that theta is pi by 4 or 45 degrees. Okay, so and pi by 4 is in the interval 0 to pi. So this is going to be pi by 4 radians. Okay, so now if I wanted to find cosine inverse of negative 1/3, so that would be cos theta equals negative 1/3. Okay, this is not a special angle. Oops. Okay, and it's not going to be a nice degree. So you can just compute this in your calculator. So in radian mode, you should have 1.91 radians. In degree mode, you would get 109.47 degrees. Okay, so you should always answer in radians, but I just wanted to show you that it's not a nice degree either. So if you did it in degree mode, you see that, and then you'd know that we're not looking for an exact answer. Okay, so again, cosine inverse of cosine is going to cancel when the angle on the inside is in the domain. Okay, so 6, obviously it's bigger than 0, 6 pi over 7, but it's also less than pi, which is 7 pi over 7. Okay, so it's in between, so it's in the domain, so they cancel out, so this would be equal to 6 pi over 7. Okay, similarly, negative 0.25 is between negative 1 and 1, so it's in the domain. So because it's in the domain of the inverse, the inside one, so they're going to cancel out, and it's just going to be negative 0.25. Okay, so here we have another one where now we're not in the right interval. Okay, it's negative, so it's not in the domain. So not in the interval 0 to pi. Okay, so what we want to do is we want to find the one that is with the same cosine value. So again, I like to use the picture, so I'm going to draw the picture. Now negative 6 pi over 7, it's a negative angle, so we're going clockwise, and it's just pi over 7 short of pi. Okay, so it's going to look like that. Negative 6 pi over 7, so it's in quadrant 3. Our reference angle here, okay, is pi by 7. Okay, that's what's missing to get to pi. So if I want the same x value, I'd want to move vertically here, and I'm going to be here. And that is going to have the same reference angle. Okay, so this is again pi over 7. Okay, so the angle that goes this way is going to be 6 pi over 7. Okay, so it's going the forward direction, 6 pi over 7. You could also do that because cosine is even, an even function, but this is going to be equal to cosine inverse of cosine of positive 6 pi over 7, because those are equal. So it's going to, now this is in the, so now this is in the interval. So it's in the domain 0 to pi. So they cancel and I get 6 pi over 7 as my answer. So if you're not in the domain, you just want to find the angle that is with the same cosine value. So tangent, so here's a couple of tangent ones. So here we want theta so that tan of theta is negative root 3 over 3. Okay, and theta has to be between negative pi by 2 and pi by 2, because that's the restricted domain for tan. So if I compute this, so if we actually did it in degree mode, so maybe you forget this one. So I'm just going to write here. So in degree mode, if we enter tan inverse of negative root 3 over 3, oops. You get negative 30 degrees. Okay, so then we can convert to radians for our answer. So that's going to be negative pi by 6. And that is in the interval, so this is equal to negative pi by 6. Okay, now this one is not a nice number. Okay, so in degree mode again, so here, in degree mode, tan, inverse of negative 3 gives me negative 71.565. Okay, so not a nice number. So you might as well just do it in radian mode, because we want our answer to be in radians, and then you should get negative 1.249 radians for that one. Okay, but that's what it would be in degrees. And just one more example left of solving an equation involving an inverse trig. So remember, we want to isolate the inverse trig function. So I'm going to divide both sides by 2. So I have sine inverse of x is equal to pi by 2. So that's the same as saying sine, not of x, sine of pi by 2 should be equal to x if you do the swap. Okay, so maybe I'll just write that. So sine inverse of x equals y if and only if sine of y is equal to x. Okay, so that's what I use to get from there. And sine of pi by 2, we know that sine of 90, that's a 1. So here my answer would be x equals 1. So that's some extra examples involving inverse trig functions.